Here we go. Okay, so now we're recording. All right, so one thing that I want to touch on as well, unfortunately, the part one didn't get recorded properly, so I'm going to kind of do a quick 15-20 minutes review of how to study for the CCNA data center. And for those of you guys that didn't see the first part of the CCNA data center series, but real quick, I just want to touch on with this slide. Why learn Nexus and UCS? Nexus is more of like the switching platform. So whenever you think of Nexus, just think of Catalyst. So the Catalyst 4500, the Catalyst 35, 6500, just replace that with Nexus, and it's pretty much like the new switches coming out from Cisco for this line. UCS, Unified Computing System. This is basically the servers, which I actually have. Where's my pictures? Oh, I didn't go over that. Well, if you just type in Cisco UCS, which actually no, let me do that right now. They kind of look like this. So you can either get standalone servers, which are pretty much like any other server out there, or you can get the blade chassis, which is just a chassis that you can slide in and out blades for that. So you kind of have like a couple different options there with that. But the good thing is with this whole kind of paradigm shift of kind of shifting everything virtual and shifting everything to like we're kind of going back to, as if you read in the Cisco white papers, I'll mention 3.0. The new data center is being we're kind of going back to that mainframe era where we had dumb terminals being in the Nexus environment, like the 2Ks or the UCS manager where everything's centrally managed. We're kind of going back to that framework, you could say. But the good thing is, if you guys want to go ahead and start studying for CCNA data center, the good things is routing and switching skills are still relevant. So it's not like, if you're going to walk into a shop that has Nexus, your routing and switching skills from CCNA or CCNP data center or routing and switching, it's still relevant. It's the same. EIGRP, OSPF, BGP still works the same way on Nexus. It's just that a couple of things are going to be a little bit different on the server side. But if you guys have been doing that for a couple of years, it's not, you won't be losing that. You won't be losing that skill set. So, real quick, this is just like a typical picture of a Nexus deployment. So, in this environment, we don't have any 7Ks here, but we have two 5Ks here. We're using VPCs here. Pointing downwards. Up here, we have two firewalls, probably some like 5520s or 5525s. Notice that my SAN is connecting directly into my 5K. One thing that you want to, if you guys are taking notes or anything, one thing that you want to know, a big difference between 7Ks and 5Ks. 7Ks only support native fiber channel over Ethernet. They don't support native fiber channel. So if you still have some old fiber channel only devices, they're gonna have to connect directly into the 5K. Down here, I have also two fabric interconnects, which is generally you get to deploy them in pairs. And down here, you also see in this case, we have two 5108s connecting into my fabric interconnects, which is basically, the fabric interconnects is basically the way that I manage my server chassis. So, there's no brains in the chassis. Everything's done at the fabric interconnect level. All right, so these are like the big pieces. If you guys want a copy of this, like email me, let me know about the big pieces. I'm just going to blow through this real quick of how to study for it. Okay, so how do I study all this? Real briefly. Now, unfortunately, as you guys probably have saw, there's not that much in terms of Cisco Press out there, at least for like an official study guide. So a couple ways that we can get some hands-on with the CCNA data center to study for that. One is go to Cloud Labs, Cisco Cloud Labs. So if I click this link here, or if I copy and paste it, First, you have to register. It's a completely separate account. It's free, but I have one already. So I'll jump in. And you have a couple labs here. Sometimes they change every so often. Sometimes it's 4, sometimes it's 5, but it's something that you can do to kind of get a feel of the Nexus environment. Try a couple commands, and it's free. So, you know, definitely take advantage of this. Next up is the UCS emulator. This is also another free download from Cisco that you can do, that you can use. I personally run it through VMware Workstation, and it takes a little while to load up, but let me just load it up here. So as you can see here, it's pretty much just a virtual machine. It's like a VMDK file that you just import into a workstation or a player. And let me see, is that loaded up? Yeah. Okay, so let me just jump into my putty. And like I said, I'm going real fast at this. I'm not going to the details. If you guys want details, hit me up offline. All right, still loading. All right, I'll go back to that later. Books. Now, there's a couple good books out there for studying, and not for the certification at least, but just in Nexus as a whole. And UCS as a whole, because as of right now, Cisco Press does not have any training books, but some good books that really stand out. First off, I definitely got to say NXOS switching, Nexus switching, next generation data centers. And when you guys are looking online for the book, make sure you get the second edition. The second edition just came out this year. It's about, I think, like double the size of the first edition, and there's a lot more in there. Obviously being, you know, double the size of the first book. So that's definitely, if I would say, if anything, this is like the #1 book that you should pick up if you're, you know, brand new to Nexus. Second off, there's another good book, Data Center Virtualization Fundamentals. This book's a little bit longer. I think it's like 1,000 pages or something. This book is pretty good too. It gives you a whole idea of data center fundamentals. But also, if you are looking for a book to kind of help you out with CCNA training, Tal Lamley actually released a book. I think he just released a second book for the second part of the CCNA data center. But there's one that is already out for the first exam, 640-911. And I think in here there is a Nexus emulator or simulator at least, so you can kind of practice some commands in the emulator since, you know, the equipment is pretty pricey. Here are a couple other good books. Storage Network Fundamentals. This is good if, you know, you're also the storage guy, or if your shop is small enough, you know, you might have to end up learning fiber channel stuff. So that book is pretty good. This book is more of a Cisco Unified Computing System reference guide. This gets more into the hardware of what Nexus does. So it's more, you know, like I mentioned, another good book to kind of get a feel of what the data center is as a whole. And I'm sure almost everybody has heard this book, Network Warrior. It's a pretty popular book out there. But if you guys get the second edition, there's a chapter dedicated to Nexus. And one good thing about it is that the author actually goes in English layman terms. He talks about the deployments. He talks about the way the setup is. So if you guys have like a chance to grab an ebook, there's just one chapter. I think it's like 40 pages. It's not long at all. So you can take a look at that as well. Some free video training on here. Now, there's not too much when it comes to video training as of right now. I know CBT Nuggets recently released through Anthony Sikora a CCNA data center Nuggets. So I don't have that on my slide here because it didn't come out when I made the slide. But one really good reference that not many people know about, and let me bring it up actually, is this link right here. through the Cisco Learning Network. So if you go to Cisco Learning Network, go to Associate, Data Center, click on the first exam, and then you want to click on Training Videos. And then right here you have like a bunch of topics. So like if you want to learn FabricPath, there's like a 70-minute video on that. You want to learn SAN and Data Center, there's another 60-minute video on here. You want to learn about basically what we're going to talk about today, the advanced features, which I'm about to get. I can talk to you guys in less than 2 hours what this is. It's not, I can give you the flyby view. It's not that bad, but here's a bunch of other videos dedicated to that. So a lot of free videos and training on that here. And if you go to technical webinars, actually coming up, what are we? Okay, that one passed already. But in October we have 2 webinars from Cisco for data center stuff. So definitely take advantage of that as well. TrainSignal also has training, but for the 1000V, which is basically the VDS switch on the VMware. So you can check that out. And I just posted here a couple of YouTube videos. I'll just copy and paste them into the chat window here. Now this is just, I mean, a lot of us nowadays is like it almost feels like, it almost feels like, YouTube is becoming like the second Google. So any question that you may have on Nexus, like Nexus 5548 or Fiber Channel or Ethernet or what's OTV, just Google it. And chances are you'll find a video somewhere about somebody making, explaining it or demoing out the config about it. So YouTube is also another good reference for it if you, want to get some overview on the topic. There's also Cisco Titanium, which if you take a look at this, and I'll copy into the chat window here, is Cisco's internal emulator that they use, or emulator that they use to emulate NXOS. It's kind of similar to GNS3, but it's not fully working. Like there's some things that you can't do in it, like you can't create a VDC. And according to Cisco, it's not supported. Like it's kind of was supposedly leaked out, and but you guys can use your Google skills and find more information about that. One good thing that I didn't know about up until maybe like a week or 2 ago. And let me get that slide. I don't want to see the demo, but there's something new that came out called the Virtual Internet Routing Lab. Which the idea behind this is that you can actually now simulate NXOS, iOS, ASAs, and it's supposed to be coming out. Like next year, like Q1, Q2, or something like that. And it's going to be like you pay for it, so it's kind of like a paid GNS3, but you can start actually, and I don't know if they have. Yeah, here's the guys talking about it. So they'll, now you can actually mess around with NXOS. You can mess around with iOS, get them to possibly, talk to each other. And if you go into, yeah, here we go. And it kind of looks like GNS3 or like a fuse of GNS3 and Packet Tracer. So, it looks pretty good. So hopefully that thing should be coming out next year. So another tool that you guys can use. Of course, there's classroom training. So if you want to go to like your nearest Cisco partner, you can take these classes. Of course, they're you're probably gonna pay a good $2K per class. That is another option. Tal Lamley also has a course as well. If you go to his site for a bootcamp on CCNA data center course. Good thing from what I hear with his data center course, you actually get to touch live equipment. Something that could be worth the money if you guys are looking to actually get hands-on and you don't have any way to get hands-on. So it's another choice. Of course, the Cisco website also has a bunch of other good references as well. So if you want to go to like the config guide, like I'll just copy and paste this guy to my browser. So if you want to go to config guide, you can do OTV quick start, and a lot of the technologies that we're going to talk about today, VPT, FabricPath, OTV, they're pretty easy to do. It's like 5 or 10 lines and you're done. So like it's really simple to do. Right here, there's a quick step 1, step 2, step 3, configuring your VLAN, how to configure OTV. it's really, I mean, as you can see from the document here, like it's not that long. It's pretty short. So if you guys want to take a look, you can see all that information here as well. And what is this guy? I forgot what I had him as. And now, well, I had a 7K up in here, but here's also one for the 5K. So this is almost like the instruction manual, I guess, you know, to using the 5K. And granted, I mean, this is like dry, it's boring, it is what it is, you know, but if you want to learn about a specific technology, like VPC, for example, generally what I'll do, so I'll go to Google, and I'll do like Cisco VPC, I don't know, like design, let's say. And as you can see here, I've clicked on a bunch of these links already. So you can click on a lot of these links, and they actually give you pretty good references. A lot of good like PDF docs, a lot of white papers on how to actually set that up. And just give it a second. So here, not only does it tell you the way to configure it, but also the design and the best practices for VPC. And this page is, this white paper is kind of long. It's about 116 pages, a little long, but it's not that bad. You can pretty much go over it. And what I'm basically going to go over for you guys here today is stuff that I've picked up from these white papers, stuff that I've seen in the field, stuff that I talked about with other guys who worked with Nexus. So try not to, I'm not really reinventing the wheel here. A lot of this information is out there for free. Another free reference that you can use is Cisco Live 365. A lot of, I mean, this is personally what I do. Like, I got a little folder here called CCNA Data Center, Cisco Live, and I actually download these videos. So if I want to know more about, I mean, I didn't folderize these guys yet, but if I want to know about, like, deploying VPC, there's the video. There's a guy talking about it. I mean, these videos are kind of long. As you can see, this is about 2 hours. So it is on the long side. They do give you for free also the PDF of these slides. So there's a lot of free information out there, and it's not just limited to Nexus. You could also, if you go into like the section here, like the filter, you can look at routing and switching deployments. You could look at switching deployments. You can look at voice, wireless, you know, whatever you want, whatever's happened at Cisco Live. If they have a video for it, you can check it out here and see if it's even available. And one little, I guess, tip that I use to download videos is if you look up here, I forget what this tool is called, download helper. So you can actually go to like the video and click download helper, and then you can download the video, which is nice because one thing is, like, you know, some of these videos are, as I mentioned, on the long side. So what you can do is you can play them like half speed or 2 times fast, and you can kind of watch them a lot quicker than, you know, the times 1 or the regular speed. But of course, the best way is, you know, to learn anything is get a mentor. So that's what I'm hoping to give you guys here today. You know, give you guys, like, instead of you guys doing the same thing that I did, going through all these white papers and whatnot, you know, let's just make the bake. It's like baking the cake once and that's it. And, like, you know, we can all share it. You know, there's no need to have 10 people doing the same thing over and over. So my goal here is to pretty much kind of help you guys not avoid all the free trainings here. I mean, definitely go through them if you guys are interested in going for the certifications, or even just for your own reference. But it's always easier to ask somebody else, you know, where should I start or what should I do? So also one thing I forgot to mention with free video training, not free, but INE has a lot of free videos on their YouTube channel, and you can use that as well. Okay, great. So any questions about that so far, guys? Are we good? Comments? No? Okay, cool. All right. So I'll move into, okay, so that took me about 20 minutes. All right, just like I thought. All right, so let's get into today's topic. VPCs, FabricPath, and OTV. And hopefully if if my pods load up here, I can even show you maybe a little bit of a demo of it. Okay, so anybody? Oh yeah, Yemi has a point here. Yemi just said if you guys are studying for CCNA stuff, they're having, I don't know if it's a promotion or if it's just what they're doing. Their CCNA level videos, at least for routing and switching, are free right now. You can stream them for free. At least as of 9/22/13. So, all right. So VPCs. I did see Mike. Michael did mention that his company is using VPCs. So basically, what is it exactly when you hear VPC virtual port channel? So basically, they're very similar to the VSS in our 45 and 6500s. But one of the key differences, and if you guys do go on interviews, they'll probably try to ask you this question. What is VPC? And actually, that brings up another good point. I go on interviews, sometimes, and people ask me, what's VTP and what does it do and would you use it? I don't know why. Literally, every place that I've gone to has asked me that question. I don't know what it is, but have a good answer for it if they ask you that question, because it seems to be, at least for me, the norm. But similar to the VSS in our 6500s, but one of the key differences is instead of having one control plane, or basically one CLI interface. And what I mean one CLI interface is if let's say I got two Nexuses, 7Ks here, I got 7K here, and I do my VPC, let's say. So this is kind of like my one umbrella. This is my VPC domain. And yeah, I'm using my mouse, so it's kind of dirty. If I plug in a blue console cable into this guy, and another blue console cable into this guy, I'll get two different prompts. Before, when we actually had the VSS, if I plug, there was something called like an active standby, or like primary master, or primary secondary. If I plugged it into the primary, I would get a little console blinking. If I plugged it into the secondary, I wouldn't get anything. Well, I mean, I would get something, but it would say something to the effect of, this is a read-only, this is the read-only peer, like go to the other one to do your configuration. So now we kind of have two brains working. And so we have two different control planes running here. But also similar to VSS, we do appear to our downstream devices as one device. So going back to my example here, like these two 7Ks looks like one 7K to my downstream devices. So any like switches or servers pointing up, it just looks like one device or one spanning tree instance, or one, like even though I may have multiple links going here, this just looks as one big pipe. You could say the spanning tree. And talking about spanning tree, this actually eliminates the need for block ports via spanning tree. So all these ports are being used. All these ports are now used for forwarding. So I mean that's a good plus now, because now we don't have to waste bandwidth. We don't have to have links just sitting there doing nothing. We can actually use basically all the lines, all our lines for passing traffic. Also, originally before too, one of the other difference is that we weren't able to port channel two devices. We weren't able to originally use two port channels or port channels to two different devices. Meaning, let's say I had my like 45K and I had another 45K, and I had my VSS domain. I couldn't have a server do this, and this is port channel. Like this wouldn't work, or at least officially it wasn't supposed to work. The good thing now with VCP, I can have a server, switch, whatever it is, and I can do this, and it works. So this is also a plus now that, I mean, maybe I could have worded this a little bit better, but we can't have a port channel to two devices, only a one-to-one. Now we can do two, or now I can port channel to two different devices. So this works out perfect because, if this guy dies, this line is still working for me. Versus before, if I just had, let's say this is one switch and I had 4 channels, you know, had 3 links bundled. If this switch dies, I don't care how many lines you have going to it. The communication is going to die. So that's another plus to our VPC. Also, I have a comment here from underscore saying no way to connect switches to the effects. Yeah, so you're not now like the 2Ks. They call these like the fabric extenders of the effects. You can't put like a 3560 to it because on this guy here, there's BPDU guard, which any kind of DTP frames will basically kill that port. But one thing that you can try doing, which I've heard some people try, on this port here that you connect to the 2K, just do just stop the BPDUs from going through, or the DTPs from trying to form a link here, so you can kind of get it working. But I've never tried in the field, so there is supposedly a workaround, but obviously, of course, it's not really supported. Okay, so it does work. Okay, perfect. So it does work for the Arista switches. Actually, it's funny. If you got a mic, please turn it on. I mean, I'm really curious to hear, your story on those Arista switches. I've heard about them, but I've never worked with them. Or if you want to type in there your experience with those guys. All right, okay. All right, if you want to just type in there real quick, just so we can. Like, other Arista switches, are they good? I mean, they're crappy to work with. You've seen them a lot. They're good for data centers and cheap. I mean, what's your take on those guys? Just your opinion. I mean, maybe it would have been cheaper to put like a Dell switch or something. Really good, expensive, and very fast. Okay. Dell's. Well, it is what it is. It's Dell. I mean, but that's what I'm saying. I mean, why? All right. So if it feels a little slow. All right. Well, I mean, why wouldn't I mean, what's stopping me from putting like a Dell gig switch in there or something instead of an Arista? Or let's say I was let's say I was your boss or your coworker or something. And I said hey, why don't we just put it in a Dell instead of an Arista? It's cheaper. I mean, what would you say? We're using the effects modules at the 5596. Okay, so you got the heavy ports. Move data express. Okay. So pretty much you're saying hardware-wise, the Dell is just, it's like you got a 4-cylinder and the Arista is like a V8 engine of the hardware, is what you're saying. Actually, for the video guys, for the guys who are seeing the this on YouTube, I'll just put this in the window here. For the 7K, we're using VPCs which bear with failover. Okay, nice. All right. Actually, now, Mike, you're saying with effects modules, you mean the 2Ks, right? So you got like a 2K going into the 5596, right? Okay, cool. All right. Very nice. 2K's a line card in the 6500. Yeah, exactly. Yumi's got it right there. So the 2K, yeah, that's basically the way they do refer to the 2K. It's just they call it the remote line card. So yeah, you definitely got that on point. All right. Last thing I want to go with a few more things I want to go with VPCs. The 5K and 7K, we can do VPCs as well. But it's generally done at the distribution, or now whatever the reason they call it the aggregation layer. So in the old Cisco books, they used to call it distribution layer, but now they call it the aggregation layer. So if you guys hear those terms, they're pretty much the same. They're talking about the same thing. Next, so what are the VPCs? Continued. So basically, when we have these two peers here, so we got like primary, secondary. We have one peer that's a primary and one is a secondary. So in this case, this actually determines during the peer link failure. This determines the behavior during the peer link failure. So the idea is that if you have, like, say, like this is a primary, this is a secondary. If the primary fails, in order to avoid loops, because we're sending basically between these two different guys, it'll kill the member ports on the secondary to avoid any kind of, I guess you say, like any kind of association with the old VPC domain because it's down. And I'll get into member ports in a second. I got a slide for that. Also, when you're doing the primary switch for your VPC generally should be also the primary for your root and spanning tree. And also, if you're doing HSRP or first hop redundancy, VRP, or if you're using Nexus, chances are you're using HSRP. You're going to also want that to be the primary device as well for the particular VLAN. So it should be the primary for the spanning tree and primary also for your HSRP instance. And for whatever reason, maybe in a future time, but you can't preempt for this. It just kind of comes up, so you can't like change that over. It's just kind of it's there by design. Who becomes the primary, secondary, as far as I saw. So also wanted to note that the VPC is a layer 2 port channel, so any layer 3 functions are not supported locally. But as I mentioned with your first hop redundancy protocol, it's supported. You could do that, and you can also route traffic between the VPCs as well. Okay, actually, just let me pull this guy here. We got some stuff in the chat. On top of the rack, Dell blade. Okay. Is it because if one monitor goes down, we just slap in the... Yep. Yeah, that is nice. That's one of like the nice things with the 2Ks. So it's kind of similar to... I mean, it's the same thing as the 45s and 65s. You know, all the brains is happening on the soups. So if that line card craps out, you just pop another one in there, and assuming that the soups are, you know, alive and well, it's just kind of like a copy paste almost. Like, you know, it's you just slap it back in there and it comes back online. So definitely a good point. The problem with the VPCs is setting up the port channel and the interport channel, so things will cost. Yeah, there's actually when I was setting this up in the lab, it's like actually I think, do I have it here? VPCs. So this is my own personal notes here. I had a weird issue where I created the port channel first, and then I did FEX, and I did this whole thing for the 2K. But I got this weird command in here called port not compatible port mode, and I had no idea what it meant. I'm like, what do you, like, I'm putting the commands in here properly. What do you mean? So it turns out that it meant that the port channel was created before the ports were put into the port channel. So I guess under the hood somewhere, you know, I'll look into that config later, but meaning that the port channel is not a flex port channel. So what I had to do is, I mean, right here, I'm doing FEX 100. I'm trying to make a 2K associate with like a 5K or 7K ports. So these two ports will be going down to that guy. So I said, okay, here's the port channel that will be in these ports. And I got this error message. So what the fix was, I just had to delete the port channel and start from scratch, and it took. So it is kind of weird. And if you do also, this is a show port channel summary command. One thing to point out is once it becomes a flex port channel, notice here that the mode changed from Axis to Fabric. Oh yeah, that too. That does help too. The capabilities or the interface capabilities. Actually, man, I hope you had. I wish you had your mic working, man, because I'm not really familiar with the Aristas. So this is interesting here. The VPC, it's the MLAG. Let me see that actually. I haven't. Enabling nursing active topologies, managing can work together, ports active or kicks into the misconfiguration. This enables an increase in bandwidth, faster failover, any layer. Yeah, this kind of sounds a little similar to VPC. I mean, I wouldn't be surprised if it's different vendors have a like a similar flavor of VPC. All right. What else we want with this? VPCs. Oh. VPCs continue. So there's a couple also caveats though, or like details that we need to do with the VPCs. One thing is that for the peer link. So let me actually. I think I have a slide here. Yeah. Let me copy this guy. Trying to fit everything in the window here. So let's say this is my VPC domain. So and this diagram is I got this off a Cisco site. It's not it's actually not that good actually. Let me use Paint. So I got my two devices. Let's say they're 7Ks or 5Ks or whatever they are. So generally what you try to do, and let's say these are like the line cards, and I know if you're using like a 7010, they're not going to be horizontal, they'll be vertical, but walk from here. So now when I say here F cards and M cards, this is kind of beyond the scope of tonight's talk. But F cards is generally going to be your layer 2 traffic, generally layer 2. N cards are generally going to be for layer 3 traffic. So the idea here is, and another good thing actually. So now VDCs come into play here as well, because when you're actually carving this out and when you're designing this, you can only have one. And I don't know if I have. No, I don't have it in here. I should write that down here. There's only one VPC per VDC, meaning, I mean, on a 7K, you can generally have up to 4 or to 8 different VDCs, which I'll get into in a second. But just because, and VDC is basically like the way you carve out different partitions in a 7K. So depending on the soup and the hardware that you have, you can make up to like say 4 VDCs. I think that's with like the soup 1 or 3 or 4 VDCs. So in here, if I have 4 VDCs, I could potentially have up to 4 virtual port channels. If I have 2 VDCs, I could have maybe 2 virtual port channels if you want to actually have them both connected to each other in that way. But let me go back to my my first bullet here. So F1 cards L2, you'll use this for your peer link to sync. So right here I have like little dash dots here. This is going to be for your keep alive, your heartbeat keep alive. So if you guys have been networking for any amount of time, chances are you know what a keep alive is. It's just pretty much just a way to ping back and forth between the two guys. Am I up? Am I up? Am I up? And generally you'll want this in its own VRF table. And they call it light because we're not using MPLS. but I'm not going to go too deep into what VRFs are. But if you guys ever go into interviews or you see designs, I've seen most of the times these are in their own VRF tables to keep alive, because the only purpose for that ping back and forth is to make sure that the other peer is up. So that's that guy. Actually, I think I swapped these guys. This should be peer keep alive, and this should be the peer link. Sorry, I think I had swapped. Okay. M cards. This is generally used for your layer 3. Now, M3 for the layer 3 keep alive, because generally, and this is even, you can make it like a VDC in here as well. And if I feel like I'm all over the place, guys, I'm trying to cram everything into 2 hours. So, you know, if you guys have questions about this, you know, hit me up offline. But M cards for the layer 3 peer link, for the control plane, for UDP pings between each switch, and hopefully, like, so basically what we're looking to do here is we got, and the little circle here means I'm bundling these two guys together. So I'm making a port channel here. This will be a trunk. So I think my slide is off here. I might have to change that. This will be a trunk, and all the VLANs you want to allow to go through this trunk here. And the reason I draw these little orange little lines here is just for fault tolerance. You want to have, let's say there's a port here, port here, port here, port here. You could actually, and another caveat or another design thing you got to keep in mind with this is they got to be it has to be at least a 10 gig link. Because I mean, if you're transferring traffic, or this, you know, if these little dots here is just a keep alive, there's got to be a way to sync these two devices together, right? So you're gonna need need at least a 10 gig link right here to transfer back and forth. I mean, we actually use here Cisco Fabric services, which is basically like the way you can sync these two devices together. But you need at least minimum 10 gigs to make that peer keep alive come up. And one thing that you could do is in the M cards, and this is something that is good to know as well, for whatever reason, as of the last white paper I read, you need this exact model line card to make the peer link work. So let me go to my Google page here. It looks like this. So this is and this is the actual part number. So if you Google this part number, this guy pops up, and if you look into white papers, this also comes up as well. This is for like a 7010. But one thing to note here, and I like the way they had this picture here, is, and this is kind of like beyond beyond tonight's talk, but one thing that you could do is these little yellow ports here, and you can see here it clearly says dedicated port. So what that means is on the line card itself, what you can do is you can run in shared mode or dedicated mode. So we had like those, the first two here were yellow, and then the rest of the three were black, or like regular ports. So behind the scenes, like behind the card itself, you'll actually, by default, it's running in sharing mode. So these 4 ports, oh, and then I see a lot of stuff in the chat, so I'll get to your question in a second here, guys. The shared port mode here says that for 10 gigs, and of course, you know, for this particular model, you want to look at the data sheet, which, let me actually do that right now. 7K M 3212. Okay, so take a look at the data sheet for this guy. Down here, there's actually another one. This is kind of detailed. There's another one. 10. Here we go. 32 ports of 10 gig connectivity. You need an SFP plus to plug anything into there. Let me do this guy. Modules. We'll do this guy, the 10 slot. Trying to find where you can compare the models. Interface maybe here. Okay, well, somewhere in here you go to the data. I just don't have. I don't want to blow too much time on looking for it, but you go to the actual data sheet, which I believe probably this guy here. I was looking for like a cleaner view, but dedicated. So in dedicated mode, the first port in the group is active, delivering a line rate performance, and the other 3 ports are disabled. So, like I mentioned, if you guys have questions more about that, hit me up offline. But reason is because if we're sharing 10 gigs on these 4 ports, if I run dedicated mode, that means this yellow port it becomes like a 10 gig port. So I can't use these other 3 ports. It's kind of like I sacrifice 3 ports, so I have that one line that can be a full 10 gig. So that's what if you know, that's kind of like me magnifying it here. So if we zoom out of this area here, that's what I'm doing here. I can have 2 line cards or 2 M31 XP12 cards. And let's say these are 2, this is 1, this is 2. I can have 2 going to the other side, going this way, to the other 7K. So this could be line rate 10 gigs, it could be line rate 10 gigs. So technically I got 20 gigs line rate to do my syncing between the 2 VPC peers. But the good thing about this is if, let's say this one, you know, one of my line cards catches on fire or whatever and it's gone, I still got another one here to still keep still keep my VPC peer keep alive going. So that's one good design consideration for that. And that's what I have here. Best to use 2 modules for the peer link for that purpose of redundancy. Want to have the peer keep alive link in its own VRF. I did mention that right here. So the link that you use here, you'll want to make it its own peer link, its own VRF table, so it's completely separate from the rest of your traffic. And as I mentioned before, if you have 1 VPC peer per VP, you have 1 VPC per VDC. So if you have up to, let's say, 4 VDCs in your 7K, let's say it's a soup 1, so it can only do up to 4, you can have up to a max of 4 VPCs. So that's one thing that also you want to keep in mind. Okay, all right, let me jump back to the questions here. Can you explain the peer link and trunk link? I have a guy that also configures routing between the chassis. Yeah, you could also do routing between the chassis if you have enough bandwidth for that. Like in this example, I'm doing 20 gigs for that. Like 10 is going to be used off the bat for your CFS syncing between the 2 guys. But you could also do regular traffic over that line as well. So yeah, most definitely. Like this, even though sometimes they say like, you know, you're not supposed to route any traffic off of here, you could. And I actually seen 2 deployments where they actually regularly use that line or that port channel for layer 3 traffic. Let's see, 4 ports share the ASIC or the yellow port only. So the 4 ports here, I might have answered your question already, but the 4 ports here, these guys share that 10 gigs by default. That's what you call share mode. So like the name's a recipe. Share mode means I'm sharing that 10 gig link. Because chances are, if you got like 4 servers plugging into here, you know, unless they're like heavy duty servers, you know, this guy might take like 1 gig, this guy might take 3 gigs, this guy might take 1, this guy might take like 500 megs. So you're sharing that, you're divvying out that 10 gigs between these 4 ports. But if you use dedicated mode, you're just saying that, hey, I just want that 1 port to use that 10 gig line. You're kind of sacrificing the other 3 guys because there's not going to be any bandwidth left for them. So that's the difference between those guys. That's why you have that little yellow port showing you that that's what it's for. Where is it? So you can kind of see this one here. So you got 1, 2, 3, 4, 5, 6, 7, 8. So you have just 8 different ASICs here. So you sacrifice these 3 ports here, and then the yellow port becomes like the full 10 gig, line. Cool. So the different pieces of the VPC. So as I was mentioning with that diagram that I had here, which I'll demo out in a second. Let me actually get that up and loaded. Oh, and I think actually my SDM got up. There we go. So this is the, I'm kind of backtracking a little bit here, but this is the emulator for UCSM. So it kind of looks like this. It looks exactly the way, like a regular one would look. But I'm not going to go into like details about this right now. I just wanted to show you guys how it looked like real quick. Exercise. Okay. All right. So different pieces of the VPC. Now these are kind of like the key terminology and keywords that people will bring up when they talk about VPC. So of course, VPC peer is basically just saying that there's like just 2 5Ks or 2 7Ks in there. So when you think of peer, yeah, 7K here, 7K here. This is peer 1 and peer 2. That's it. You can only have up to 2 only, so 2 max. So you can't have like 3 peers or 4 peers. You can only have 2. The peer link, like we mentioned before, is kind of like the lifeblood of the VPC link. Generally, you want to have at least 2 lines for redundancy for that link. It carries the control traffic between the peers to create that like that dummy or that that way of making for the downstream devices that there's actually one 7K or there's one 5K on that tunnel, or to those guys, the rest of the guys. Cisco Fabric Services, this is also what I mentioned before. That's actually the protocol used to synchronize our 2, and it also goes over this over the peer link. It makes sure that both 7Ks are in sync. The peer keep alive link, this is your heartbeat link, layer 3, which I think I might have flip-flopped them on this side, but the heartbeat link is going to be a layer 2 link, so it's just basically just an IP address, and that's why I have like the little dots. That's just going to be an IP address. Can I ping you? Yes. Can I ping you? No. To make sure that it's up. And the peer link down here, this is the port channel or the trunk that we have down here. This is layer 2. And up here, this is a layer 3 for the keep alive. Layer 3 link. And then VPC member port. Now this is what I mentioned before earlier to you guys about if a VPC dies or a VPC peer dies. So if this guy catches on fire and he's gone, by default this is secondary. So this is active. The active blows up and catches fire. The secondary, the member ports, like these guys going downstream. Basically, member ports are the guys who are actively, they're participating in VPC. And I got a port channel down to, I don't know, like a server or a 5K or another device. So one port that forms a VPC going downstream to a different device. That's basically what it is. If the downstream device looks up and sees you as a VPC domain, then he's a member port. And that's not like something you configure. You don't go into like the 7K and you don't type in like, you know, member port this. It's just like the terminology for it. VPC domain, that's pretty much the umbrella of the two devices. So when I mentioned before that these two guys, if they're synced together, this umbrella is called VPC domain. Or almost like the same thing with like VSS domain. Like this is just one umbrella that makes it look like it's just one device. Okay. Orphan ports. Now these guys are more or orphan device and orphan port. As the name kind of implied, it's a device that's not connected to a VPC peer and not using a VPC link. So that's kind of like saying, you know, I got let me clean this up a little bit. So say I got 7K, I got a 7K. I got my keep alive, I got my peer link, and I got, let's say down here, I got a, I don't know, let's say I got 2K. Got a 2K, I got a 2K, and it's doing VPC. So I got cross links. This link is a VPC. So the 2Ks look up and they say, oh, this is my VP. This is one logical. This is one device that I'm looking at. But notice here too that I got two links. One goes to 7K1, one goes to the other peer, 7K2. So that's going back to the fact that if this guy blows up, catches fire, and this link is dead, I still have this other guy who goes up to the second 7K. So, but if you, and like I said, this is more like a band-aid. It's not a long-term thing. If a device that's connected to the VPC peer, it's not using a non-VPC link. So that's like saying like, I got VPC looking down, but out of the blue, I just connected to here a server, like a C200 UCS server or something. This will be considered here your orphan port because he's not actually connecting into the VPC peer, so he doesn't have like, it's not like he's connected to these two guys. This is not a VPC, so this will be considered like this wouldn't be that. So it's considered a orphan port, or this will be the orphan device. Okay, so I see from had a link here. Oh, the emulator, Faisal. Hope I pronounced your name right, Faisal. I'm actually just remoting to a pod for this, so it's not like an emulator that I'm using for the VPC demos. Yeah, and from the this UCS here, you could actually, and I think somewhere in here there's a like a backup. Where is it? Policies. I think actually admin. Backup config. So you could like make a config, and then you could like import or export it. And I think it's like an XML file, so you can like literally copy and paste it. So it's pretty nice. Let's minimize some windows here. Okay, just give me a second. I'll load this up. Okay, so I'm just downloading the PDF for this. So we're gonna have a topology here, and sorry it's kind of small, but I have two 5Ks here. So here's like a 55, like 48. Here's a 55, another 55, 48. And what I'm going to use here is, as you can see here, I got two lines, and they're bundled. So one of these guys is going to be my, it's going to be my port channel. It's going to be my peer link, and we're going to have another link here for my keep alive, peer keep alive. And notice down here, I got a 2K down here. I got a 2K down here, and this whole thing here is going to be like a VPC down to these devices. So I can demo that out for you guys, and also as well, there's a couple of commands to actually verify that, and I also got a little like walkthrough of how to set that up. It's pretty straightforward, but I want to show you guys, since I'm assuming a lot of us here don't have access to this, to these devices. So at least if you guys want me to show any commands or do any kind of commands here, I can show you guys here. So at least you guys kind of have a chance to see how you guys do this. Get my chat window back here. Okay. So by default, admin is going to be like when you first create or when you first get a Nexus out of the box or NXS OS device, it's going to be admin, and I think it's blank by default, or it asks you to make a login. So real quick, and I'll make this a little bit bigger so you guys can see it. I'll just do it for one because I can't fit it in the recording. But if I do show inventory, very similar to our 65s and 4500s. Right here, I said I got a 5548. Got some fans, some power supplies. I got a layer 3 daughter card, so I can do some like native layer 3 switching on here, because the 5Ks aren't really meant to do switching or layer 3 operations, so it's mostly for layer 2, but you can modify that by putting a layer 3 daughter card in there, which is just basically a card that you pop in to make you do layer 3 stuff. So that's that. Show version. Same thing too. Right here I got, where am I? I think it's 5.1, I want to say. Where is it? 5.2 system version. So as of right now, I think the most recent one coming out is 6.2. So this is a little older. And the first release of Nexus was 4.1. So if you're only 4.1, 4.2, you got like the first generation stuff. 5.2 is kind of like the second generation stuff. Okay. So let's do this. So if I do show CDP neighbor, let's see what I got to begin with on here. And I'll drag this guy out a little bit so I can see better. So according to this, I can see, I mean, we're not going to pay attention about the switch down here, but I want to see my core, the other end. So I got 15 and 16, and the same thing here. I should also have 15 and 16, so that's good. That pretty much, let me see my diagram here, 15, 16, I got 17, 18 on my diagram here, so it's probably these ports actually. So let's actually name this so we can actually make sense of it for the CDP stuff. So we'll call this like Nexus 1. We'll call this guy Nexus 2. And let's do a CDP again. Oh, one other thing too I want to point out to you guys, you don't have to, you don't need to do a show command anymore in Nexus. It'll take, but you could actually, similar to the ASAs, I could just do show CDP neighbor right there, and it'll take. So right here, I can see here I got Nexus, the other side of my Nexus switch here. So that corresponds to my document here. I got port 17, port 18. So we'll use that as my port channel for my peer keep alive. So let's try that. Let me move to that section. Okay. So first things first, you want to do a feature VPC on both sides, because now the new thing with Nexus is that you have to actually enable the feature before you can actually, the technology before you can use it. So we'll do that. And I'll actually follow with my steps over here. So you want to do feature VPC, and because we're going to be using a port channel, we'll also use feature LACP. So we can't do like in PO1. Well, actually we could, because there's a layer 2 port channel. But if I actually want to use a layer 2 negotiation, I'll need to enable that. So I'll do like, if I do channel, for the ports. So let's do port E21. What do I got here? 116, let's say. Channel group 1, mode, say on. That's interesting. It looks like it takes. So they'll be using like VCP, LACP, but we're supposed to enable it first. Or it might already even be enabled. So you can do a show feature, include enable. So I don't have enable right now. Cool, so that's done. And let me kill that PO1 because I don't want that guy. Cool. Alright, cool. So now let's do to configure the VCP domain with a number. Generally, I've seen like 1. If you you can only have 1. It's like kind of like BGP. You can only have 1 per VDC. So I just keep it at 1. So let's do that. We'll say VPC domain 1. VPC domain 1. And I'll hit question mark. And I got a bunch of different options here that I could do for my VPC. So one of the requirements that we're going to need is pure keep alive. That's one of the first ones that we're going to need. And we'll actually also do a port channel, and in there we'll specify that's going to be the peer link. So nice after we've done that, let's assign IP address to both ends of the peers and ping to ensure that we can reach each other for the peer keep alive. And I'm actually just looking at my pod here, what IPs I need to give it, because it's specific. Okay, so in this case, we'll use actually we don't have anything in here. So one thing that another thing I want to mention to you guys, the show IP interface brief, that no longer gives us like a big list of all the interfaces that we have on the device. So it's actually going to be show in brief, and that'll show us everything that we have on the device. So right now I'm seeing here management 00. Management 00 is just like a separate, like, it's like a second console port on the Nexus. So if I do show int brief, does this guy have it? Okay, he does. He has 174. This is 173. So let me just do a regular ping from the basic or the default VRF. Alright, doesn't work. So if I do the same thing, I'll put VRF, and I'll say management, because according to this, the VRF, actually it's not a VRF right now, but let's give it a shot. Okay, so it works now. I'm getting 0% packet loss, so we'll use the management interface for that. And I should be able to do the same thing on this side as well. 10, 2, 8, 1, 4, 3, VRF. By default, out of the Nexus, I only got a default VRF and have the management VRF. So I'll ping using the management, and I should be able to hit the other side, which I am. I got 0% packet loss. Okay. So in this case, I mean, in my example, I just said, for my keep alive, I said E0, 0, no switch port, because once again, these Nexuses are switches out of the box anyway, so you want to make sure that you put in there no switch port to turn that guy into a layer 3 port. We'll put it in its own VRF. In my case, I called it meetup, but generally you'll call it like, you know, VRF keep alive or something. Give it an IP address, and of course do a no shut. And then just verify that you can pin the other side. Let's say the other side was, you know, whatever the other IP address is. I just use 1111 to make it easy. VRF meetup. Okay. Next I'm going to define, now we got that out of the way, so we're able to get the keep alive link up. We actually didn't like set up the keep alive yet though, but we just got the regular layer 3 connectivity for, at least for the back and forth, so we know we got some like basic layer 3 connections going. So let's actually define now, let's make it say that, okay, I'm going to use this interface for my keep alive. So I'm going to go back to VPC domain 1, and under here I'm going to issue the command peer keep alive, and that's like the key command there. And I'll say destination, whatever the other side is, and if I'm using a VRF, which probably 9 times out of 10 I'm going to do, I'll say the VRF, and I can optionally source it from a certain interface or a certain IP address. And once that's done, then we're going to verify that with the show VPC peer keep alive to make sure that the keep alive shows as okay. So since we're under the interface already, so I'm going to do peer, and I'll minimize this a little bit so you guys can see that. It's kind of tight, but peer keep alive question mark. I'll say destination, and the other side was this IP address here. VRF management question mark, and I can say the source as well. So here I can say source, and just to hard code everything, I'll say definitely 10.2.8.173, because this 173 is my IP address on my end, and this IP address is the IP address of the other end. And I'm saying that I'm going to be using the VRF of management to do that. So if I do here, I show VPC peer keep alive. So right now it's saying failed because I didn't configure it on the other end yet. So let me jump to the other end and let me do the same thing. I'll do peer keep alive question mark, and one thing is definitely abuse the question mark, guys, when you guys are doing this. Just same exact thing as you do with your in the regular iOS. The best way to learn and learn different commands, and just kind of like a little bit of a sanity check for on your end. So we'll say I'm gonna pin the other end, which was not that guy. So if this is his source, that'll be his destination. VRF management, and I'll do source of 10.2.8.174 because that is this is my end. I'm sourcing it from my end here. Done. So now let me issue again, show VPC peer keep alive. Now instead of showing suspended destination not reachable, I'm getting the peers alive. So at this point, I got my peer keep alive working, and in my little paint diagram, in my case I got 5Ks for this example. The little dots is done. Chuck. So we got that done. And also we created the umbrella called VPC domain 1. So that part is done too. Okay. Next, we're actually gonna put the main piece, which is called the peer link. This is the port channel that we're gonna use. We're gonna bundle 2 interfaces at least. I mean, in a lab like this, we could do just one, but we'll probably want to do at least 2 for redundancy. So, and I think actually you might even have to specify a port channel. I forget if it's specific on the 5K or the 7K, where it makes you use a port channel. So, so in my example, I just said, you know, int e1 to 3. I'm using 1 to 3. So I'm using 3 ports. I'll call this port channel 1 mode active. I'll turn it off. I mean, no shut. I'll make it a trunk. And I'll say, and this is the key command here, guys. You want to say that this link or this port channel between 2 ends here is the peer link. And no shut. And this is the basic commands in here. I mean, optionally here you can say switch port trunk, VLAN access, and you can put on there the VLANs that you want to allow. But for the lab, I'm just going to keep it basic. So, and in our example, we're going to use, I know it's kind of dirty here. Let me clean this up a little bit. E117 and E118 is going to be my peer link. So under here, I'm going to use, let me start on, whoop. I'll start on switch 2. I'll be, say, 117 to 18. And notice I don't need to use the range command. I can just say, I can just put interface E117 to 18. I'll put it in a channel group 1 mode active. And I'll no shut it. Done. Let me go to the other side. Let me do the same thing. And just to keep it simple, I mean, you don't need to use the same exact interfaces, but it just makes it easier to keep everything uniform. Done. Okay. Now next we want to go actually into that port channel. So we call the port channel 1. And let's jump back here. We'll say that it's a trunk, because that's what it is. We're going to be passing the VLANs between and the syncing between the 2 different peers. So we'll say switch port mode trunk. And once again, that key command, which is going to be VPC peer link. And no shut. Optionally, too, what you can do, and this is saying, please note that the span tree type has been changed to network on the VPC peer link. This will enable bridge assurance on the VPC peer link, provided that the spanning tree bridge assurance is not disabled, which by default it is. So I just kind of give you a little message. It's kind of like a little info message. It doesn't really, you know, it's not going to break anything. And let's do it on the other side as well. Oh, by the way, let's do right now, show VPC. And if you guys are actually like trying to troubleshoot this or just looking at regular show commands, there's not that many show commands to verify VPC, which is a good thing, because, you know, there's only like maybe 2 or 3 commands. So show VPC, this is saying here that the peer link is down because the other side is not reachable over CFS. CFS being, once again, that Cisco Fabric Services. But our peer link is working. That's what we verify with the management port. My pings back and forth worked. Configuration consistency failed because it didn't work. You know, we don't have that up yet. And right now for my VPC peer link, I'm using port channel 1. Okay. You can also do detail. Oh. What's that command? Or consistency? Oh no, brief, sorry. Show VPC brief. Kind of gives us the same information, but I guess brief. The brief version looks kind of the same. I always use, for the most part, show VPC brief. But one way also that you can do another command that's used often is show peer keep alive, which in our case, as we saw before, the peer keep alive is working fine. Okay, we go also do show run VPC, so we can see this actually in the show run. So I enable the feature, that's good. Here my peer keep alive is working fine, and here's my port channel. that is enabled as a peer link. So that's good. But the only thing is, if I go back to my show VPC brief, my peer link is still down because I got to go on the other side. So let me jump onto the other side. I'll go into the port channel. I'll do switch port mode trunk. And once again, that key command, VPC peer dash link, and no shut. You can also do here, guys. You can do a show port channel summary to verify that he's up. According to this, he's showing us down, so I might have to shut that guy. I'm gonna do I don't think I did a no shut on the port channel. Let me shoot it again. Okay, so that's what it was. So now it's showing SU. S is layer 2. Oh no, sorry. S is switched. The U is for up. So up in port channel mode. So now I'm in P passive. That's good. So that's another thing you want to check out for when you're making this. Make sure the port channel is up. So technically now my VPC should be up. So I'll do show VPC brief. And now we're seeing peer status, peer adjacency formed OK, and peer is alive. So this is good at this point. So we created the port channel. I mean, granted, this is a 5K, so we're not, we don't have redundancy because it's just one box. But we got that up on 2 links. So that's good. Now the final piece here, what we want to do is configure the VPC for our downstream devices. So in our diagram here, where is this, guys? In our diagrams here, I got 2K down here and 2K down here. So this looks like right now this is my VPC domain, just one device or one 5K. But one thing is also that I have to actually manually say what my downstream devices are. And I'll show you what I mean by that in a second. So let's say in this example here, get rid of this guy. So here, I'll just clean this up so you guys can see it here. So I got, this goes to here, and I'll use a different color for, this goes to here. So in the red, 2K1 has 2 ports going to 1, 2 ports going to 2, and the same thing for FX2. I got 2 ports going to 1 and 2 ports going to 2. So this could be like one big VPC. So let me see. Let me do a show effects. Let me configure that. So let me do a feature effects. Turn that on so I can. Okay. So also another thing I want to mention, guys, when you guys are working with the 2Ks, you have to enable that feature. And as you saw here, show effects didn't do anything. But after I enable it, now I do show effects, and I can see now I discovered 2 different 2Ks, which is my 2Ks down here. Thing is, though, nothing's configured yet right now, so it just will stay in a state of discovered. Okay, so one thing that we can do now to actually get that going, once we enable show effects or future effects, we can give each one a name or a number. So I can say this is like 100 and this is like 101. So if I do effects question mark, you even see that it gives you 100. You can start at 100 up to 199. So you kind of got like 99 possibilities or 100 possibilities. So I'll start with the first one. This is another thing too with the 5Ks. You can either say you can do dynamic pinning or static pinning. And in my case, I'll just say I'm going to do I'm going to pin this to 1, and that's kind of outside, a little outside the scope of VPC. So you guys have questions about that, just type in the chat window or email me or contact me afterwards. So we'll say one link that I'm going to use to actually connect to that 2K, because I'm going to use my port. I'm going to create a port channel downstream. So technically, I got one link going down there. And I'll say, who was it? 7 and 8. So these two ports 7 and 8 will go down to this FEX here. So let me specify those guys. 7 and 8. And I'll say you're in channel group 7, 8. So we'll keep like the same number here so we can reference it easier. So now let me go into the port channel. We'll call it 7, 8 so we can link. I'm basically saying port 7 and 8, you're a member of port channel 78. So now let me go into port channel 78 and actually let me go ahead and start configuring some of the parameters in there. Let me do a question mark. I mean, nothing really out of the blue here. I mean, this is similar configuration that we do with any kind of port channel. But the only difference is here is because since this is actually going to be going down to a 2K, to a FEX, we're not going to call it access, we're not going to call it trunk, but we got a new mode here called FEX Fabric. No choices, so I'll hit enter. And you also want to give it the number, saying that, you know, that's the number that you want to give it. So I'm going to call him, this is my line, my remote line card 100. Could be any number, but so you could say FEX, I'll do question mark. I got no other options, associate, question mark, and I said 100. Okay, now let me do a show FEX to verify. So now notice here, guys, that before it was just set as discovered, but now I'm seeing it as my FEX number 100. My description, I didn't put a description, so I just put a default one in there. If you want, you can say description, you know, rack, you know, like line, like row and rack 2 or something. If you want to, like, you know, be specific where you have in the data center, and the state. So I'm in connected right now, so that's a good thing. So now if I do a show int brief, hit enter a couple times. I don't see it there yet, so I might have to give it some time. I actually also should get a little syslog message, little messages that pop up saying that the FEX is online. So I'm gonna do show. Oh, here it goes. Sometimes it takes a little while for it to come up. And this is the money line right here. FEX 100 is online. That's what you're looking for. Okay, so that's the case. Let me do a show FEX again. I'm seeing online. So online is like kind of like you said, like a final state. And I'll do show FEX detailed. And we see some pretty detailed stats about this particular remote line card. What version of the FEX code is running there. Serial number of the guy. The model number, the part number, and the ports too. So I'm connecting to it using these ports locally on my 5K. And down here are my remote line ports. So right here, since I called it FEX 100, I identify this FEX here with 100. I also have here port 1 and like module 1, port 1. And so it's kind of similar naming convention. You can see it this, so you know exactly when you're configuring multiple FEXs on a single 5K or 2K, you know which one you're looking at by the first 3 numbers right here. So if I do a show in brief, those numbers will now appear in my show IP in brief. So I pass my local ports on the 5K. I got some port channels here. I got my layer 3 interfaces here, and then all of a sudden now I can see my remote line card ports here. I think I got 48 or something. Yeah, 48. Any questions on this, guys? Or I mean, it's a pretty. I mean, it looks a little complicated the first time you see it, but it's a really straightforward. Pretty straightforward when you actually do it a few times. And of course, here are a couple of verification commands that I did mention. I did show VPC. That's showing that the peer adjacency is okay. The peer link is alive. Perfect. Show VPC consistency parameters. This is a way that you can kind of check if this should be global. It's a way I can check if for whatever reason my VPC peers are not forming an adjacency. It's kind of similar to a routing protocol. It's like, you know, you want to make sure what's going on. Why is my adjacency not forming? You can go in here and it'll show you. Basically, you want to get these two parameters to match to a T. Once they match to a T, the peer link usually comes up. From? Yeah, definitely from. I will. Here's my email, my Skype info. I'm on Skype like almost all the time, so it's really easy way to get in touch with me. And my phone number and as well. But I'll paste it in the chat window. Okay. Show VPC brief, of course, is the same thing as show VPC, but of course a briefer version of it. Show port channel capacity. I don't really use this command too much. Let's do question mark. Capacity shows the capacity information. Oh. So I can make up to 1,600 total port channels on this 5548. 2 of them are used up because I created 2 port channels. I have 598 free and 0% used. So I guess if you have 1,000 port channels, this would be this would be a good command to use to see, you know, how many port channels you have. You can also use I believe usage. Yeah, usage. Which this is more for like if you're in a VDC. Because one thing, and unfortunately they don't give me access here to modify VDC parameters, but if you're running a full-blown 7K, because you can only do VPCs on 7Ks, you can say you may have you could limit how many port channels or VLANs you create per VDC. Just, you know, so this way like one VDC isn't like oversubscribed to the hardware. You can use this command here to see you know, how many you've used and how many you have unused. Show VPC role is another one. In this case, even though on the Nexus 1, I have the secondary role. Here's my MAC address and my role priority. And funny enough, I got the role number or the priority number is really similar to the default spanning tree priority. I think it's like 32,687 or something like that. And as I showed you guys before, show VPC peer keep alive, which shows that my peer keep alive, my layer 3 ping between the 2 different devices is alive and okay. Cool. Okay. Actually, let's jump to one thing. I'm looking at the time here. I'm about 1:30, so I got about 30 minutes left. Let me actually jump to OTV, because I see OTV used a lot more in the field than FabricPath. What do you know? Let me just clean up some windows here on my end. It's kind of messy here. In the meantime, guys, while I load my next info here, do you guys have any questions so far, comments on anything so far? And looking at the time, I might end up doing a part 2 to explain OTV, FabricPath. Actually, before I even get into OTV, has anyone actually implemented or is working in a data center or enterprise right now who's using OTV? You can turn on your mic or chat in the chat window if you have. Okay. Actually, by the way, from, I mean, do you mind just typing your name? Because I kind of feel funny calling you from. Lee. All right, awesome, Lee. Lee, did you implement it, or you just do vMotion, or you just use it on a day-to-day basis, or did you help implement it? Just out of curiosity. Okay. All right, nice. Well, good news is you didn't really miss out on anything. There's not much to it. It's pretty straightforward. Yeah, it connects to data centers. So I mean, pretty much, I think we all know the main reason, one of the key points to use OTV is basically a way to connect multiple data centers to each other. It's sometimes people call it like a stretch VLAN. You can have 2 VLANs in one VLAN in 2 different data centers. Whereas before, if you were using like MPLS or whatever, or you did some crazy routing stuff and BRF stuff, you can kind of fake like a stretch VLAN between 2 different data centers. But the beauty with OTV is that it's a very short-term fix, and I'll get to why I call it short-term, because it's a way that I can simply pop in 5-10 commands and get 2 data centers to join each other and make it look like they're on the local LAN, like you said, Lee. Now, the reason I said short-term is because it's great short-term, but it works for the moment, but if you really want to get the full capabilities out of, like for example, vMotion or disaster recovery, or for whatever reason you need to spin up a new site of 1,000 people or whatever, and you don't want to be bothered about public IP addresses, you really take the biggest bang for your buck. And I'm actually still learning this as well. But if you bundle Lisp, and I don't know if you guys have heard of Lisp before. Cisco Locator ID Separation Protocol. You can go through, I mean, there's a ton of white papers here, I'm sure, but basically the idea behind Lisp is that I can have, it's almost like having a DNS entry for your IP address, but globally. So instead of having, the issue where I have problems with, like for OTV, I have to jump from one data center to another, and you kind of do suboptimal routing if you vMotion certain machines. Lisp takes care of that issue for you, but that's outside the topic of today. But that's just one thing I'll give you guys the heads up on, that if you want to efficiently use OTV long term, you want to get Lisp involved in there as well for a better long term fit. One other good thing about OTV too is that built into OTV, there's no broadcasting of information, and one of the things of that is anything STP related stays in the data center. So you could have, even though the VLAN is being stretched to 2 different data centers, STP doesn't stretch over, which is nice because now you have a smaller domain to have to worry about. OTV, all it needs is basically similar to our peer keep alive. We just need a ping, or we just need like a way that we can reach, just like ping the other end, and we're good to go for Lisp. I mean, there's not that much requirements. you also preferably will want multicasting enabled for that. So, I mean, you could use something called adjacency servers to do unicast without using multicast, but it's a little bit more work and not as efficient long term. Most people use multicasting when they use the OTV. Also, if you guys, and let me see if I can find it. There's a good article that I made called OTV Decoded Fancy GRE Tunnel. They go into like the whole explanation of how, even to the config, they tell you how to set up like set up OTV. So once again, guys, I am not reinventing the wheel here. A lot of this information is out there for free. I'll paste this into the chat window. But as you can take a look at that INE article, but OTV uses GRE tunnels, but has some built-in capabilities already made with GREs to stop, for example, SDP, ARPs, broadcast storms, and kind of keeps each data center as an island. So all these little problems that we had previously get solved with OTV. Okay. Also, you would want to generally keep OTV control plane traffic off OTV, but keep data plane traffic going on there. So this is going to be your like, for example, one of the biggest selling points is vMotion, and also disaster recovery as well. Also, things like having VLANs in 2 sites, but they will be in 2 different STP domains. Thus, we can have VLAN overlays without any complications, which is kind of what we touched on a little bit earlier today, or I mentioned earlier today. A couple things too is OTV does not support fragmentation. So whenever you actually enable OTV on the join interface, which we'll get into in a second what a join interface is, you want to make sure that you enable jumbo frames on that guy, meaning that you want to change the MTU. So generally I've seen MTU like 2916. So under that interface, you'll put that there so that it could actually go ahead and support the bigger frames, because we're putting more information into that layer 2 frame. So that's kind of like or the packet, because you're putting frames into packets, and when it pops out on the other side, it'll get rid of the packet and turn back into a frame. So that's what we need that extra room for. A good thing is also that OTV is kind of media independent. So I can run OTV over anything, whether it's like optical, MPLS, point-to-point, whatever it is, I don't care. It could be a satellite, as long as I can actually ping between the 2 points. Also, as I mentioned just before, you don't need to use multicast to run OTV. It's one of the requirements that you don't need to hit, but it's actually recommended that you do. But if for whatever reason your service provider doesn't do multicasting, you could do unicast, and this is where you use your adjacency servers, which is, as I mentioned, a little bit more legwork, not as efficient. It's it's not, like, I guess you could say, the best use of resources, but it's kind of like a way that you can get up and going, at least if you don't have the multicast option. Also, layer 2 flooding isn't done over the OTV network, but done by the OTV control plane. So it's actually when you, and let me click on this link again for the INE article here. So it's kind of like the way it works that OTV keeps a little, kind of like a table, saying if the device name, the IP address, MAC address, and there should be another one here, like a exit interface. So if you want to reach a certain device via the MAC address, there'll be a kind of like a table, and then you can actually pick which, if it's a interface being local, or if it's the IP address of the other data center will be put here. So you're routing by MAC address. You're not routing by IP addresses. Okay. Also, multi-homing can be done as well with OTV. You use the authoritative edge device for this. So, and actually, you would want to do this anyway because, of course, IT, the name of the game is redundancy. So, if you have one site with 2 sites of OTV, so I got a site here, I got a site here, and let's say this is my OTV cloud. let's say DC1, DC2. I would not want to have just one link here or one port channel or a join interface doing this, because if that port channel or join interface dies, of course that means that sucks, because all of a sudden now my I lost my OTV connection. So generally you'll have two. And also, so this, of course, if one dies, you have one still forwarding traffic. But the way we pick who's going to be like the main guy who's speaking to the OTV cloud will be known as the authoritative edge device. So if this is my main speaker, he's my AED, and the other device here will be my join interface, or my regular. It's kind of like he's on standby, you could say. Also, one of the biggest things with OTV is it's generally deployed in its own VPC. Sometimes they call this as like OTV on a stick, or OTV stick, or one arm, or this is basically the way that I can go ahead and get around. I think I might have it in here. No, I don't. So OTV can't work with a VDC that has SVIs. It's one of like the caveats or the design not flaws, but for whatever reason you're not able to get OTV and SVIs working. It's something to do with like flooding and looping. So for that reason, generally when you make OTV on a 7K, you're gonna create its own VDC, have its own VRF for that traffic, and for the most part, when you actually create the OTV, you would have your internal interfaces. And I'm actually getting ahead of myself a little bit, but internal interface. Let's say I have a VDC. I have my, say this is an M card, this is an F card, and this is like a 6.2 release. So as of NXOS 6.2, for my internal interfaces for OTV, and as the name kind of implies, internal means this goes back into my local LAN inside of my DC. These can be F cards, and these ports here will be known as internal, because that's going back into my internal LAN here. Authoritative edge device, as I mentioned, that's like my multiple ports that I can use to join that OTV cloud, or that OTV multicast cloud. And the edge device here is the device that's responsible for all OTV functionality. So basically, this is the guy, if I have an OTV dedicated, let's say this is my OTV, that OTV VDC, he's my edge device. Even though we're not talking about a hardware device here. Like even though the whole 7K, like the VDC lives inside that 7K, but that particular VDC would be known as like the edge device. And of course, if this is going out, these are my M card. One of them will be my AED. He'll be the active forwarding, and the other join interface, who's joining my OTV multicast cloud, will be kind of like in standby. And that's kind of where we come in with this slide here. A join interface, one of the uplinks of the edge device, usually used to join the OTV network or the OTV cloud here. The overlay interface is also a new virtual interface that contains all the OTV config. So one thing that we're going to do, and I'll demo this out for you guys as well, instead of saying, we're so used to saying like int VLAN 1, you know, or I mean that's the most common one, or like int tunnel. In our case, we're going to say like int overlay, and in here we're going to have, you know, yada yada yada. In here we're going to have our information that's going to say what cloud to join, what OTV cloud to join, what VLANs I'm going to stretch over, what's my site ID, and we'll get into that in a second. Now I also have extend VLANs and site VLANs. Extend VLANs is, as the name kind of implies, is the VLAN that I'm going to stretch. This, you can even call this like stretch VLAN, but they call it extend VLAN in the command line here. Is the VLAN that I'm going to cross over that OTV cloud or that layer 3 network So it pops out on the other side as a layer 2 frame. So that's like the way that you can kind of make a VLAN live in 2 different data centers. And the site ID is used to select the AED, and it's something that the peers use to talk to each other. So here I got 2 ports that are connecting to my OTV cloud or my multicast cloud over here. So I would have a VLAN here that's dedicated as a site VLAN. And once again, the name is the recipe here. Site means it's going to be locally at my site. And I put those ports into that VLAN. And it'll help to say who's going to elect who's going to be the main speaker, the authoritative edge device, or the main, the primary talker to the OTV cloud. And actually, I'm looking at the time right now. Let me just speed through this here. Let's just jump into the configuration. Let me see here. How can I... So I got my 2... I got 2 7Ks here. They're in their own VDC. Let me get you a diagram here. So we're going to say that we'll say this is data center 1. This is data center 2. And this is my cloud up here that I was referencing in my paint here. This is my OTV cloud, which is being represented by 65. So I want to go ahead and extend over VLANs 1, 200, 200, 300. So I got 100, 200, 300 living in DC1, and I got 100, 200, 300 living in VDC DC2. And I'm going to go ahead and join the OTV cloud, and at least show you guys the initial configuration for that. So let's do that, and I'll go ahead and use my PowerPoint slides here to follow through. So let's jump into this guy, admin. So let's see what hardware we got working here. So I'm working with the 710. What else do I got here? I have 2 backplanes over here. I got SOUP 1. And here is my model numbers. I got 2 line cards here as well. And some power supplies and fan modules here. Do I have any layer 3 interfaces? Okay, so I got a loopback here. And let's take a look at the rest of my layer 2 interfaces here. So I don't got too much I don't got too much here in the ways of layer 2 interfaces. So, and this is called 7K1, and this guy should be 7K2. Okay, 12. So K1 1, 7K 12. All right, and this should be the same exact stuff. I got 710, so that works. And here's gonna be my 65. Show version. I'm running 12.1. Nothing crazy here. It's just a regular. Just a regular 6500. I'm running SOUP 32 here. Okay, so first I'm going to go ahead and configure the backbone. So I'm going to simulate my OTV cloud with the 6500. So one thing is we're going to be using multicasting here. So I'm going to have to enable multicasting on the 6500. Oh. IP multicast routing. I'll also do a show CDP neighbor. I gotta enable some ports here. Because everything's shut down. Show CDP neighbor. Okay, I'm not seeing the 65 here, but I got the right ports that I got to enable it on, so I'll just go ahead and do that. Gig 2.1 IP address. Now let's do regular 10 addresses just to make this thing simple. We'll use pin sparse mode. That's the most popular one of the two, not dense. And also use IGMP, and we use version 3. Version 3. Whenever you do OTV, you also want to use version 3 for multicasting whenever possible. And I'll turn this guy on. And I'll do going towards the second 710. Gig 2.2. And that's very similar configuration. And generally, when you guys actually deploy this, or anybody deploys this, what I'm actually typing out right now, you don't really need to know per se, but this is more for like your service provider would do this for you to actually enable multicasting between the two different sites, or the line that they're going to be giving you. Version 3, do shut. Okay, and I'll do one more gig 2.3. Sparse mode. I'm just actually copy and paste a lot of this stuff in, but okay, so now let me do a show CDP neighbor again. I'm going to have to enable it down on these guys. I'm going to have to turn these interfaces on because, oh wait, alright, I'm seeing here. So I got two links going into my OTV cloud on the 710 on the left side, and I don't have anything. Okay, now I see it on the right side as well. I see the two ports come online. Okay. So let me go ahead and I'm going to do OSPF routing to actually just learn some of these interfaces here. Luckily here on the iOS, I don't have to worry about turning on any features, but actually let me just do a copy and paste from this side. Done. Advertising networks on my interfaces here, these guys. Or I could have done like an all zeros too, that could have worked as well. So let me jump to the first 710. And I can see here that I'm using 1.3 to get to the 65, so let me go to that guy. So T. Now let me do IP address. I'll make sure I can join him on the right subnet. We'll shut, and I'll do the same thing for port 4. Shut. right, and I'll do the same on the second 7010. Okay, and now also let me enable so I can get some neighborships going between the 6500 and the Nexus 7Ks. So I'll enable feature OSPF. And now the difference is with Nexus though, if I do like router OSPF, I'm gonna have to do it at each at the line level or per port. So we don't no more have like router OSPF 1. There's no more network command. So that's something that's new with Nexus. It kind of resembles a little bit with the with IPv6 that we're gonna have to do it actually at each port level. So we enable it at the interface level. We don't have to enable it anymore globally using this network command, which makes things actually a lot easier. So let me go here, router OSPF 1. Let me start that process, and I will enable it on ports 3 and 4. OSPF area 0. So this is the way that I will actually go ahead and enable OSPF process 1, and he's going to be in area 0. And so whatever IP address that I gave port 3, he's going to just now join area 0. Makes things actually, I think, a lot easier now. And I'll do the same on the second one. Okay, so let me jump. I got an adjacency up on my 6K. Try to OSPF neighbors. Okay, well, I don't want to spend too much time on that. I just want to get at least one side up so I can show you guys the commands for that. All right, so now let's jump back to my slide here. First, we're going to enable on the OTV VDC, we're going to enable feature OTV. We're going to turn that on. So in this case, we'll go this guy because he seems to be the one cooperating right now. Feature OTV. Oh, and by the way, guys, you actually need, if you want to enable this feature, of the correct license. It's called the transport services license. If I do show license usage, you want to use the transport services for that. So if you don't have transport services on there, you'll get that 120-day grace period. And also, by the way, if you want to use VDCs, you also need to purchase another license, and I believe it's this one, the Land Advanced Services package. Okay, so now that's done. I'm going to go ahead and create the overlay VLAN or the extend VLAN. I'm also going to create my site VLANs. These are going to be just local VLANs that I create locally on that OTV. That's probably why you can't have SPIs working there. So say VLAN 101, and we'll say under here, do a question mark. Actually, no, okay, so that's done. Let's get out of here. We'll do question mark here. And I can see up here, now I got some OTV commands here that I can use to start configuring some OTV VLANs. So I'll do OTV question mark. And now I can say my site VLAN, and I'll call him 111, the guy who I just made. All right, and I'll also do my site identifier. It's kind of like a router ID for your OTV. And I'll do 1.1.1. Well, you could put it like in a MAC address format because once again it's like we're doing MAC and MAC routing. So I'll just do 111 because it's similar to my VLAN over here. This is more like an informational message here. You don't have to worry too much about that. And on the other side, I'll do something very similar. Actually, did I get any? Okay. Not sure what's happening. Maybe I used the wrong IPs, but just for demonstration purposes, I'll do the same. OTV site VLAN. Oh, I got to turn on feature OTV. Usually you want to do that too, guys, if you don't get, for whatever reason, the commands you want, maybe enable the feature. So OTV site, there we go, site VLAN, that's what I'm looking for, 112. And I'll give it the router ID. It's kind of like the router ID for OTV. Site identifier, 112. Okay, now we're going to start configuring also now the, where's my paint? The joining or the internal device that's pointing back to our LAN. So we actually did this. We created the, like in this example, I said VLAN 10 and VLAN 20. We already created here the OTV site identifier, and we can go ahead and start actually. On my slides, I kind of skipped a step of the internal interfaces. So let's do that here. Let's say my internal interface will be, let's try to say here 2.5. So he's going back down to my LAN interface. So he's going to be a switch port because once again we're doing LAN traffic, layer 2 traffic here. Let's say switch remote access, switch port. Access VLAN 111, because we said 111 is going to be my site VLAN. I'll no shit this guy. And the other side too, I'll do the same thing, but I just will say 112. Pretty much same thing. Now let's say we said the VLAN that we want to extend over was 100, 200, 300. So my example, we'll just use 100. I'm not going to do all three. This is just demonstration. So we'll say like name extend. We'll say so under we'll pick VLAN 2.3. I mean interface 2.3. We'll call it switch port because once again this is going down to like say like effects or one of my servers or a host. 100. No shut. So internally, it's gonna look like, you know what? This port is going down on my internal interface. Is going down to, like I said, like a server, a switch, whatever it is, that's being VLAN 100. But of course, we want that VLAN 100 to eventually go into the OTV cloud and pop back out to the other data center. So what we're going to do for that is, and this is where my slide picks up, we're going to create that int overlay interface. And when we actually configure that int overlay interface, these are a couple of the commands that I did mention before. It's pretty simple, straightforward. It's like 5 to 10 commands. We got to specify, and this is where multicast comes into play. The control group, the data group, what VLAN that you're stretching or you're extending. In our case, it's going to be VLAN 100. And you also want to specify what interface you're using to join the OTV cloud, or what's the M card port that you're using to join that cloud. And if you haven't already, you have to enable IGMP version 3 on the interface. So it's pretty straightforward. I will push this to the side here so we can see it better. I'll do int overlay and just a regular number, let's say 1. And if I do a question mark, you can see there's not that many commands that we can do here. So OTV question mark. I can, and this is where the adjacency server comes into play. That's if you're doing unicast with OTV. But for the most part, the primary commands you can use is these 3 guys right here. So it's almost like from top to bottom. You can say, make sure you do this one, make sure you do this one, and you do this one. So control group, I said here 139.1.1. My data group, I says 231. Oh, and another thing is good with Nexus. We don't have to worry about 255, 255, yada yada yada. We can just put the silent rotation in there, which is nice. And also we could specify the extend VLAN. Oh. What happened? Can I not type? What's going on? Oh, OTV extend VLAN. And you can put in the VLANs that you want to add or remove to that list of VLANs that you're going to stretch over to the other data center. In our case, we just have 100. And then you want to bind the join interface. So we're going to say in this example, just for demonstration, I'm going to keep the same thing here. OTV join interface. What interface on the M card that I'm going to use to actually join the OTV cloud. And then it's either port channel or Ethernet. In my case, I'll say 1.1. And just reminding you, hey, by the way, you gotta enable IGMP version 3 on this interface if that's the one that you could be using to join this OTV cloud here. And that's pretty much it. It's really straightforward. I mean, granted, for lab purposes, I can't fully demonstrate that to you guys, but a couple verification commands, and some of these probably won't work properly because it's it's in a lab environment. But this slide is pretty good because it shows you the verification commands that we could use, that we could go ahead and use. And that's pretty much it, guys. I mean, I'm past my 2-hour limit. I see some guys falling asleep here, so I'm just gonna wrap it up.